In media communications, 5G is the fifth-era innovation standard for broadband cell organizations, which mobile phone organizations started sending worldwide in 2019, and is the arranged replacement to the 4G organizations which give availability to most current cell phones. 5G organizations are anticipated to have more than 1.7 billion supporters worldwide by 2025, as indicated by the GSM Association. Like its archetypes, 5G organizations are cell organizations, in which the assistance region is isolated into little topographical regions called cells.
All 5G remote gadgets in a cell are associated with the Internet and phone network by radio waves through a neighborhood receiving wire in the cell. The fundamental benefit of the new organizations is that they will have more prominent data transmission, giving higher download speeds, in the long run up to 10 gigabits each second, gigabit per second. Due to the expanded transfer speed, it is normal the organizations will progressively be utilized as broad network access suppliers for PCs and PCs, rivaling existing ISPs like satellite web, and furthermore will make conceivable new applications in Web of Things (IoT) and machine-to-machine regions. 4G cell phones can't utilize the new organizations, which require 5G-empowered remote gadgets.
The increased speed is achieved partly by using additional higher frequency radio waves in addition to the low and medium band frequencies used in previous cellular networks. However, higher frequency radio waves have a shorter useful physical range, requiring smaller geographic cells. For wide service, 5G networks operate on up to 3 frequency bands: low, medium, and high. A 5G network will be composed of networks consisting of up to 3 different types of cells, each requiring specific antenna designs as well as providing a different trade-off of download speed to distance and service area. 5G cell phones and wireless devices connect to the network through the highest speed antenna within range at their location.
A few organization administrators use millimeter waves for extra limits just as higher throughput. Millimeter waves have a more limited reach than microwaves. In this way the cells are restricted to a more modest size. Millimeter waves additionally experience more difficulty going through building walls. Millimeter wave receiving wires are more modest than the huge radio wires utilized in past cell organizations. Some are a couple of centimeters long.
Monstrous MIMO, various information numerous yield, was sent in 4G as right on time as 2016 and ordinarily utilized 32 to 128 little receiving wires at every cell. In the right frequencies and design, it can build execution from 4 to 10 times. Multiple bit streams of information are sent all the while. In a procedure called beamforming, the base station PC will ceaselessly figure the best course for radio waves to arrive at every remote gadget and will arrange different receiving wires to cooperate as staged clusters to make light emissions waves to arrive at the gadget.
Latency in 5G. The error latency in equipment shipping in 2019 is 8 to 12 milliseconds. The latency to the server must be added to the error latency for most comparisons. Verizon reports the latency on its 5G early deployment is 30 milliseconds. 30 edge servers close to the towers can reduce latency to 10 to 20 milliseconds. 1 to 4 milliseconds will be extremely rare for years outside the lab. The 5G latency KPIs, key performance indicators, are standardized by 3GPP in TR 28554.
Speed 5G speeds will range from approximately 50 megabits per second to over a gigabit s. The fastest 5G is known as mmWave. As of July 3, 2019, mmWave had a top speed of 1.8 gigabits per second on AT&T's 5G network. Sub-6 GHz 5G, mid-band 5G, by far the most common, will usually deliver between 100 and 400 megabits per second, but will have a much farther reach than mmWave, especially outdoors. Low-band spectrum offers the greatest range, thereby a greater coverage area for a given site, but is slower than the others.
Error rate 5G uses an adaptive signal coding system to keep the bit error rate low. If the error rate is too high, the transmitter will switch to a less error-prone coding mechanism. This sacrifices bandwidth to ensure a low error rate. The range of 5G depends on many factors. A key factor is the frequency being used. mmWave signals tend to have a range of only a couple of hundred meters, whilst low-band signals can, in the right circumstances, have a theoretical range of a couple of hundred kilometers.
Massive machine-type communications (MMTC) would be used to connect to a large number of devices. 5G technology will connect some of the 50 billion connected IoT devices. Most will use the less expensive Wi-Fi. Drones transmitting via 4G or 5G will aid in disaster recovery efforts, providing real-time data for emergency responders.